So guys, you're welcome to my channel once again. In my previous video, in the last video rather, I talked about the connection of a PLC. Just like this, I showed you how a PLC can be connected to as a direct online to control the start and stop of an induction motor. So this is a recap of that video, but I will advise you to go through the video if you have not gone through it, because I will not be going into details on it now. I'll just give you a quick summary so that we can go into what I have for this video, which is the programming of the PLC. We'll look at how the PLC is being programmed to start and stop a motor. So this is just a physical connection. This is the stop button and this is the start button. So we have to be taking note of where the stop button and the start button are being connected. Like if you look closely, you will see that the stop button is connected to X0. This is X0, and the start button is connected to X1. So you need these two information on the programming, so you know how to program your stop and start button. Also, you need this information too. This is the indicators. This light comes on when the motor is on, and this light, the red one, comes on when the motor is off. The output of a PLC is usually 24 volts. So in a case where you don't have a 24 volt contactor, which is usually the case, we all have a 220 volt contactor, which is very common. So what we normally do, we also have a 24 volt relay, is also common. So what you will do is you use the 24 output of the PLC to power a relay, which will now close this normally open contact of the relay to supply the 220 volts to a contactor, and it starts. So that's the simple way of doing it. Except you have a 24 volt contactor, you can just connect it here. Instead of it going directly to the relay, you can go straight to the contactor. So, and the output is being taken from Y0, while our stop light is taken from Y2. This is stop light, the stop light wire is taken from Y2, and the start light is taken from Y3. So we need these five inputs and output information. We know that the X0 is for stop, X1 is for start, Y0 is for the output, Y2 is for the stop light, and Y3 is for the start light. So this is the programming environment, or the programming software rather. This is GSWorks2. You can see it. GSWorks2 is used to program Mitsubishi PLCs, different kinds. GSWorks2. So you just have to download it and pay the necessary fee for activation. So this is GSWorks2. We'll be using it to program our Mitsubishi PLC. So after this video, I'm also going to give you a video of how we can use a HMI to also start and stop a motor instead of pressing a button, a physical button. You just have to press an icon on the screen. I'll also show you how to program a HMI. So just stay tuned to my channel, and if you have not subscribed, use where to subscribe, for I have an interesting videos for those in the industry and those in the college to help you. Alright, so let's go ahead. The first thing we will do is to create a new project. So you go to project, go to new. So you can see series of PLC. We have so many series of PLC, but for this video, I'm using FS-CPU PLC, FS-CPU. So you select it. Then for the type of PLC, we have different types. You can see we have the different types. So under the FS CPU, we have these types. If you choose another series, you have different types displayed. So for this video I'm using FS2N. It's a simple project and language is ladder. Let's leave it like that. Now click on OK to take you to the programming environment. Depending on how fast your computer is, it should appear less than a second. Alright, so this is the programming environment. You can see how it is. It has an empty field. So we are going to write our ladder logic here. Just stay tuned. So don't forget what I said. Our stop button is labeled as what? S1. Start button labeled as X2. No, sorry about that. Stop button is labeled at S0. Start button is labeled as S1. The output that powers the relay is labeled as Y0. The stop light is labeled as that should be Y2, and the start light Y3. You can always go back if you forget it. So this is it. We are right. So let's continue. So what we're gonna do now is I have to start from the stop button, and the stop button is usually normally close contact. So I'll click on this. This is where it is. The ladder logic is where you pick the one you want. You have the timer, you have the normally open, normally close, the output, everything is here. So I go to the normally close contact to label to program my stop button. I said it's X0, so I'll write S0 here. I'll write S0, so you can see that's S0, and I have to program my start button label as what? S1. I will now go to normally open contact, which is this. I'll select it and write S1, X1. Then I will now put my output, which is Y0. So I'll select an output coil and put Y0. Yeah, see, it's complete now. It's complete, just what I need. But I've not programmed the indicator lights. That's what is left. But we need to add a returning contact here, because when you press the start button, this output will come on, and when you remove your hand from the start button, it will go off. So this is why we need to put a returning contact. So you put the returning contact here. And how do you do that? Look at me. You put a branch here. You place your cursor here. Add the returning contact. And it should be normally open. It only closes when the output closes, and it's a function of the output. So we'll use the output to represent it, which is what? Y0. See, Y0. And now close my contact and complete the circuit. So you see I've created a returning contact, which is what? Y0. Alright, so let me go ahead and program our start and the start indicator and the stop indicator. Remember, our stop indicator is on Y2, and our start indicator is on Y3. So don't forget this. So I will write stop indicator, which is when Y0 is off. When Y0 is off, so I will use a stop. It's also a normally close contact. Y0. And it's what? Y2. So the the stop indicator light is connected to Y2, so I have to put an output coil and place Y2. That's Y2. So you can see. Then our start indicator is, that's when the motor is not okay, when the motor is running. So that should be, this also Y0 and Y3. The start indicator is Y3. So now I will use a coil. Whenever you want to represent an output, you use a coil Y3. Alright, so let's just go through it once again. So this is our stop button, this is our start button, this is our returning contact, and this is the output that powers the relay. Okay, so when you want to program our indicator lights, this is our stop light, and this is our start light. Stop light, when the motor is not running, this will be on, and the start light when the motor is running. So this is a simple program on how to control the PLC to start and stop a motor. So I will just compile it and debug it so you can just see how it works. So I'll click on compile and rebuild it, then click on debug, start simulation. It will try to transfer the program to the PLC. So you can see it's transferring the program to the PLC. I'll click on close. So as you can see, nothing has happened. Our Y2 is on. You see it, the Y2 is on. If you actually make a physical connection on this, so you have actually make a physical connection of this, when you power your circuit, you discover that this light will just come on. This red light, it will come on, just like it is here. It's on. So when I start the motor, when I activate Y0, it should go off and Y3 will come on. Now let me activate Y0. You click on this. This is the start button. So I want to press it to come on. So you go to debug, modify value. If you can see it's off. So I need to put it on. Let me put it on. So watch what happens to this, and this. Then I put it on. It's now on. So you can see our Y0 is on. The Y2, which is our stop light, is off now. The Y3, which is our start light, the start indicator light, is now on. So do you see? So even if I remove my hand from the start button, everything still remains on through the returning contact. Now let me release my hand on the start button. You can see I have released my hands on the start button. The start button is off now, but the motor is still on. It is on through the returning contact. If I want it to go off, I will have to press the stop button. If I press the stop button, the start indicator light will go off and the stop indicator light will come on. So let's see. Let me press the stop button. I'll hold it, I'll press it, I'll put it on. So you see, I'll put the stop button on. You see the motor is now off and our stop light indicator has come on back. Alright, so guys, that's just a simple program for the PLC to start and stop the motor. My next video, I'll be showing you how you can use a HMI by pressing the start and stop button will be programmed on the screen. You just have to touch it to start, touch the stop button and it to stop. Alright, just stay tuned for that video. It's an interesting one. See you guys, bye.